Welcome back. This is the 6th video in the series Getting to Know Cimatron NC. Today I'll be discussing 3+2 machining. I have a file with an NC setup that defines the machine, target part, fixture part, and the stock. Most importantly, it also locks the user coordinate system for post-processing. I've created a user coordinate system for each tilt of the table to machine the slide body, each with a thoughtful name. I've also created a 3-axis toolpath with clearance set to 50 mm above the part. For the video, I will create a volume rough spiral procedure for each tilt. They will have a Z bottom limit to stop machining relative to the chosen user coordinate system. This process should be familiar to most experienced 3-axis users. There are a few differences to consider. A 3-axis user would usually group together every procedure based on its tilt direction, like a top setup or a bottom setup. For 3+2, the user can group by tool changes, like roughing side 1, side 2, and side 3, all with the same cutter. A 3-axis user would also place the user coordinate system on a location relative to the actual pickup in the machine. For 3+2 users, the user coordinate system locked in the NC setup defines the pickup of the part in the machine. For each of the tilted user coordinate systems, the tool axis is parallel to the Z axis. Taking a moment to hide the toolpath and display the remaining stock, you can see how the part was processed. Each new procedure relies on the previous one to define the stock volume it uses for the calculation. Machining occurs only where stock exists. Using the machine simulator, we can verify the toolpath and that all connections occur in safe locations. Watching the simulation, we can see the stock removal from each tilt, each stopping at the defined Z bottom. Experienced 3+2 Cimatron users realize the importance of the user coordinate system, both its orientation and its name. For users new to Cimatron 3+2, I'll simply point out the preference option when applying templates to use the original user coordinate system. This matches UCS names from the template to the UCSs in the file they are being applied to. The orientation of side 1 doesn't have to match for a template to be used. Only its name and the intent to rotate to its Z-axis vector. Thanks for watching. Join us next time for Pocket Manager and Volume Pocket.